Hi, everyone. So first of all, I just want to thank all of you who put some time aside to sit here and keen to learn more about news agencies, more specifically Reuters. So I'm here on stage with Kirk Kaiser, technical evangelist from Datadog, and my name is Romy Rodani. I'm an associate architect at Thomson Reuters. And I'm here to present how and why we have built a live video streaming platform which has its streams being viewed by billions of people. But first, before I get into that, let's just quickly explain who are we and what do we do. So Reuters is the largest international multimedia news agency in the world. We are the news source for the news network you watch. We are a wholesaler, which means we sell content to customers such as the BBC, the CNN, the Washington Post, and the New York Times. We have a global footprint of more than 2,500 journalists collecting and getting content from more than hundreds of bureaus on a daily basis. Our news coverage gets pretty much anywhere, right? The global reach can go up to 1 billion views on various platforms, such as web portals, television, newspaper, and even radio. Reuters is famous for its unbiased, accurate, and swift breaking news coverage, but also for its innovative ideas in technology. And that pretty much goes hand in hand anyway and enables agility. We can easily say that we are a frontrunner in technology and fundamentally an engineering organization. And with that, I do hand it over to Kirk, who is going to give a few examples about that and how we innovated in the past.
Cool. So before we get started, I thought it would be helpful if we built a bit of historical context for what we're all doing here and talked about one of the largest improvements to the speed of communication in the history of mankind and kind of get a feel for how it impacted the way we perceive the news. So I'm talking about the telegram, and in its day, it was almost an incomprehensible change in communication speed. So people went from literally waiting months to receive messages from overseas to being able to send messages in minutes. And so as we're working constantly with new technology, things are changing, rules are changing, everything is kind of shifting. And in the same way, back then, technology wasn't evenly distributed. And in particular, when the Lincoln assassination happened, there was no working transatlantic telegram. So the news of Lincoln's death traveled overseas by a patchwork mixture of telegrams, steamship, and news pigeons. And the steamship itself actually took 12 days after the assassination of Abraham Lincoln for the news to get to Europe. And so Reuters was just in the beginning of setting up a technology platform using telegrams. And so he actually scooped this news story by first intercepting a mailboat off the coast of Ireland. And then he built a private telegraph for 50 miles all the way through to Cork, and then forwarded that telegraph from Cork on to London. And so they got the news actually hours before the ship landed. And so people were able to react in the financial markets hours before anybody else knew this huge event had occurred. And so along with the change of the telegram being unevenly distributed, inside the US, we actually had an entire network of telegrams by this point, and it had started to affect the way that the news had been delivered itself. And so in this case, in the United States, we got hourly updates on information on the Lincoln assassination. And so newspapers and their presentation of what the news was very quickly changed internally. And so if you look, I believe it'll be on your left, you're going to see one of the common newspapers in one of the loyal states inside of the US. And so that entire front page is covered with information and details and investigations about what was happening in the immediate events following the Lincoln assassination. By contrast, because Europe had to wait for a steamship and had to wait for 12 days and had to wait for these packets to arrive in time, they perceived the news in an entirely different way. To the right, you'll see the entirety of the story for one of the largest newspapers in London at the time of the Lincoln assassination. And so we hear, we're getting shorter communication times, and this radically changes everything, right? We've completely transform the way that news is perceived. And so the telegram for a news organization like Reuters was really only the beginning. They've been around for over 150 years. And so they've dealt with shifts constantly and maintained their edge in delivering the news consistently as the platform that news gets delivered on has changed. And so it's wild to think about, but they've lived through things like the radio and how that changes delivery of the news, cable, the invention of satellite, dealing with satellite feeds, and what does that mean for the delivery of news? And then now, currently, in this generation, the internet and cloud, right? Thinking about cloud computation and how that shifts and gives them and lets them continue to keep that leverage in their specific field. And so Reuters itself is a news ingestion and distribution platform, right? And so they have a few things that they're trying to think about in terms of every new technology that comes around, right? So first and most important is being consistently first with news that matters most. And so they're constantly reevaluating how it can beat the competition by being consistently accurate, reliable, and first with that breaking news. And because they have downstream news agencies ingesting everything they have to always be accurate, right? Their reputation is of a paramount importance. And so with that, I'm going to hand it over to Romeo, and he's going to talk about building the latest generation of news delivery for Reuters.
Thank you, Kurt. So as you have seen, Reuters has a long living past of being an innovator and technology-focused company. But we do deliver content in various formats, starting from pictures, scripts, and news metadata, and videos as well. We have a large archive going back to 1896, which consists of more than 1.5 million individual clips and 700,000 or 800,000 actual news stories. So you can imagine we do have a lot of content as well, and all of that actually stored on AWS. But we quickly realized that we need to, we realized that video news coverage real time is also critical to our business. And initially, we have built a satellite distribution system around it and a head-end environment, which still has its space because with the satellite, you have an infinite consumer space or consumer capabilities. And because it's all based on IP multicast capabilities, everyone who have a correctly configured satellite receiver and correctly authorized satellite receiver, they could receive a live feed anywhere in the world, basically. But internet became more accessible. And that's, we realized we have to invest into that. And that's how the first iteration of Reuters Live emerged, where initially we relied on someone else's expertise to serve our highly valued content for us in the digital domain. Just keep in mind, that was 5 or 6 years ago. But in parallel to that, we started playing with the cloud. We realized its cost-cutting capabilities, the power of AWS, and how you could potentially start doing live streaming over the internet through AWS as well. And that's how the second iteration of Reuters Lives emerged, where we really just tried to prove whether we can deliver broadcast quality and stable streams via the internet from AWS. The third iteration is what I'm going to talk about today, is Reuters Lives, and you're going to see on this small video. It's based on the proven success of live streaming in the digital marketplace, and based on the proven success of efficiency, cost-cutting capabilities, and the scale you could achieve with AWS. So what you can see here is the platform where you can take Reuters Lives, use it, integrate with it, take the player to embed it within your websites. Reuters Live is a solution which provides up to 6 simultaneous, globally distributed, Reuters-gathered, low latency, source-verified live streams. It's also distributed in multiple resolutions and protocols, such as RTMP or HLS, HDS. It's compatible with most of the hardware appliances, CDN providers, and social media providers. And we can pretty much get a feed from anywhere in the world. So what did we have to do to achieve that? Well, as I mentioned, we were using a third party. We realized we could do better if we would just be going all in on AWS. And we wanted to take full control of our streams and manage our own transcoding capabilities and transcoding profiles as well. So we knew that we should do that. And because we built some expertise with AWS, we realized that you should really go full on with serverless where you can. Like, seriously, serverless is just awesome. Like, why would you not use it? Like, it takes care of all of those additional overheads and infrastructure management piece that you just don't need to care about anymore, like all the scaling capabilities, patching, and the underlying infrastructure itself, right? But Of course, because we do transcoding, which is quite resource intensive, there are cases where you cannot really use serverless. And that's where we use those awesome instances that AWS provides, the G3 class or G2 class when we first started it. So we made use of hardware acceleration. And hardware acceleration is awesome because it not just makes it more cost efficient to do transcoding and video processing, but also just makes your infrastructure more efficient because it offloads all that additional work from the CPU itself. And the CPU can deal with all the additional tools such as your monitoring, your logging, or even the network stack itself. And you basically avoid having any kind of additional artifact within your video by not overutilizing your CPU itself. One thing I do want to point out for the GPUs, if you use those instances, just make sure that you turn off the auto boost capability because it actually does throttle your underlying GPU. So yeah, just make sure that that's just a small thing that's probably a good takeaway that you should probably turn off if you want to fully utilize your underlying infrastructure. So as we are a wholesaler, we need to meet all of the requirements of our customer's customer as well, which means we need to have the capability to easily ingest content and to make that flexibly or easily to consumable as well. And what I mean by that is we need to take content from anywhere in the world. Well, it sounds easy nowadays, but if you take a location where you can hardly get a 3G connection on your phone, then it's pretty difficult to create and deliver a stable, high-quality, broadcast quality stream back to somewhere and then redistribute it globally. And we did solve that, and I'm going to explain a little bit about that later. Because we, again, as I mentioned, we need to provide feeds to our customers who then sell it to their customers, we need to make sure that we provide those in multiple frame rates as well. Because we have people who watch our news feeds on cable television, for example, which means we need to meet the common standard conversion and the frame rates that you can find within EU and US and Asia, 25 frames per second and 29.97. And that sometimes can turn out to be fairly difficult if you need to do that. And we need to do that on a scale from small to large events as well, which means we do create news events based on just a localized car chase, but also we cover the Trump inauguration or the royal wedding as well, which you can imagine quite different from the scaling perspective. So let's look at some other streaming challenges that we had to deal with. So streaming is a quite interesting beast because there are so many conflicting technology choices, right? I'm sure everyone who have played with live streaming before have run into this. It's like even if you just look at the protocols, if it's CDN friendly, it's not so much ultra low latency, such as the HTTP fragmented protocols like HLS and HDS. It's nice because you can cache them, but it's not that low latency, even if you tune it. And then if it's ultra latency, then it's not so much CDN friendly, like RTMP, for example. And there are even differences on the transport layer itself, because if you look at, like, UDP is awesome. It's one-way. It's much faster than TCP in general. You can use IP multicast, which increases your scale. But then you need to deal with the loss of your content potentially. There are ways around it. You can create forward error correction, and that's something we are doing with our satellite-based feeds because you have to. You need to send more content to make sure it actually gets there, or it can be recalculated or recreated if some content is lost because of the weather, for example. But then again, there is TCP, which is stable, but then much slower in general. But then you can do caching with some of the protocols on that. And it's one-to-one, so you cannot use IP multicast. I guess one point with UDP as well that you need to make sure that your firewall is configured as well. And TCP on port 80 and 443 is usually something that people open up anyway. And then as I mentioned, frame rates. It's a big challenge because from the ingestion perspective, we get content from anywhere. And that means we can get content in various frame rates, 25, 29.97, 30, 50, 21, whatever frame you can just imagine, basically. And we need to create a common standard out of that, which is 25 and 29.97 in most of the regions globally. And if you imagine that you take a video feed or a live feed, which is 25 frames, for example, because it has been shot in Europe, and you want to rebroadcast it or retranscode it and then deliver it to consumers in US, then you need to put it into or recreate it in 29.97. Well, as you can imagine, you need to create some additional frames, which can turn out to be fairly difficult, especially if you have some fast movement on the picture, such as, for example, a Formula 1 feed. And what we did there is, you can do quite high-quality motion-compensated frame rate conversions, and that actually does solve it, but it's fairly difficult in the cloud still. And there are various compression techniques such as H.264, H.265, VP9. I mean, I guess everyone tends to move towards H.264 and then later on to H.265 with 4K. But again, just so many conflicts, right? I mean, where are the actual standards? It's almost like there are too many. So how did we solve some of these challenges, and how did we solve the challenges I mentioned in the previous slides? Well, we just went pretty much full on with AWS. I mean, you can use this as a reference to just look at how many different services we used within AWS to create a large live streaming platform. And we pretty much just tried to look for any kind of functionality and try to replace it with either a managed service or a serverless functionality or something that can just help us to deal less with the underlying infrastructure, but more with our individual business logic or the actual application itself. So, we use CloudFront pretty heavily as a content delivery network, I guess, to name a few. I mean, Lambda, that's, best friend. And I guess one thing about Lambda that I didn't mention as part of the hardware acceleration, so we really pushed the boundaries of going serverless. And what we did with video processing as well, and I can tell you more about that after this session if you're interested, is with stamp function and Lambda functions, we did actually try to chunk up videos into very small 5, 6, 10-second chunks based on the iframe boundaries. And then using step function in parallel, we started to do the transcoding on individual chunks and then stitch them together with a Lambda function afterwards, and effectively creating a video within the time of the transcoding the Lambda took to create the largest chunk. Think about that for a minute. Like, we just abused the nature of the parallelization capabilities of Lambda. And basically, we transcoded a file much quicker than you would do otherwise with FFmpeg or a normal EC2 instance, for example. So what's our architecture look like? I'm sure everyone can relate to it. We have some inputs into the cloud, and we have some outputs from the cloud. But I guess, in all honesty, it's a bit more complicated than that. I mean, even this is a bit simplified. But I guess what we have here, if we start from the left-hand side corner in the top, as I mentioned, we need to take content from anywhere in the world. And the way we have solved that, we have camera crew and journalists out there trying to shoot the feed for us and get some breaking news. And they have a small equipment with them which enables them to create bonded cellular network connections, and basically out of a couple of SIM cards and mobile network connectivity, create an HD stable stream to actually have the capability to send content from anywhere in the world, even if the connectivity is not really great, back into our headquarters on high quality. So we get the content back from the camera crew into the headquarters in EU and US. The reason why we still have some on-premise infrastructure, because obviously, agencies still run out of some physical data centers in a way, and you need to have a master control room and seeing every feed in there as well. But there are other reasons. I mentioned frame rate conversion. We still need to do that with on-premise hardware for real-time feeds. It's really difficult to do motion-compensated frame rate conversion on real-time live videos yet, at least cost-effectively. I guess you could throw all the power underneath and maybe you could do it, but that wouldn't actually worth it. And then we also need to add our own specific watermark onto the feeds. So we have the encoders in EU and US, and we prepare the feed in a protocol that's ready to be shipped to the cloud or internet accessible, such as RTMP, because that's also fairly low latency. And then once we have the content in the cloud, we have the EC2 instances with G3, 16x and 8x large instances with a couple of GPUs in them, doing the hardware acceleration and transcoding for us into various protocols and transcoding profiles. We have, as I said, we provide adaptive bitrate as well, which means that we have streams starting from 140p, 200 kilobits per second, up to 8 megabits per second, 1080p. And I'm sure at some point we need to provide 4K, and there's not much requirements for that yet, at least from the news perspective. Then once the content is ready to be distributed to our consumers, we provide various options such as RTMP, because that's what Facebook, Twitter, and various social media platforms require. Then some of the hardware appliances also, in terms of if you want to make it low latency, then you utilize RTMP. And then we also make it available in HLS, and we use CloudFront to distribute it to our digital customers, and we use, again, another separate CloudFront distribution to distribute it to our broadcast customers who have a specific hardware we provide to them. So the way our customers can take it is through the platform that I have shown on the video. It's actually called Reuters Connect, and that's where people can take Reuters Lives. And once a person actually subscribes to that, based on what they see in the platform in terms of what sort of news events they're looking at. That actually triggers a couple of API calls back to a fairly critical component, which I'm going to describe later, and it's completely serverless, called a stream manager. The stream manager is what really does most of the heavy lifting. That's really the interface between the content management system that the live editors are using within the, when there is a new event coming up and we have a new breaking news. Obviously, you need to create some metadata, some rights and restrictions, who can use it, where you can use it, and which encoder it should be going out on. So the CMS, what you see on the bottom, is sending all the metadata information to a Kinesis stream into the stream manager. The stream manager has a couple of Lambda functions, which reads those Kinesis streams, which has the metadata of a live event, puts that into DynamoDB, and then from DynamoDB via an API gateway and another couple of Lambda functions, the upstream systems can consume that, and people can subscribe to it, and we can show it to our customers through the web interface of Reuters Connect. We also use step function to create recordings of our lives, which can be later on used as VOD or any kind of interesting work that machine learning and deep learning could be applied there. But that's why we have S3 on this and the step function piece. So we have an additional orchestration for creating video demand workflows as well. We use SNS for stopping and start and stop signaling our live streams, because as you can imagine, there are some live events planned in the future, and then at some point, someone actually comes to the podium and you start the actual live event itself for the customer. We realize that there are some level of latency differences if you use SNS, or sometimes SNS actually gets there quicker than a Kinesis metadata or a metadata on the Kinesis stream itself. So we have like an additional backup for our managed service, I guess, as well, at the same time of trying to increase the latency in between when someone actually started. But that's really pretty much the simplified infrastructure. So this is the detailed diagram of the actual infrastructure with all the additional upstream and downstream systems which connecting to our feed to, because all the satellite-based distribution system is also connected to this. And what's important from this slide, I guess, and I want to mention, is just the fact that we're trying to follow the same principles what we had on our on-premise infrastructure. And that's making sure that we have high availability and resiliency by basically making everything multi-region, right? So we have, obviously, lots of journalists covering or getting news for us, but also we have 2 headquarters actually physically built out in EU and US with multiple encoders. We also utilize multiple regions within AWS, even for Stream Manager and even for the serverless infrastructure itself. I mean, it doesn't hurt much to have another CloudFormation deployed somewhere, right? So it's something we do. We also have multiple distributions depending on the use case in terms of platform. So if it's a broadcast use case, separate platform distribution. If it's a digital use case, then another separate platform distribution. And all the other upstream systems also follow the same principles. So Reuters Connect, also multi-region, and most of that is also in AWS. So let's talk a little bit about the Stream Manager. So as I mentioned, it's really just a combination of Lambda functions, reading Kinesis streams, and then putting that into DynamoDB, and also with step function, creating some additional VODs and putting it into S3. So this is a concept that we came up with because it's just something that we felt like we need to have like an actual orchestrator in between the upstream systems and the underlying stream itself. And it's something that manages our engines and the streaming engines and the ones that actually provide the streams. It's also something that's managing our metadata ingestion. It's managing our database. It's creating all the push publication of the RTMP streams if someone subscribed to a live stream and wants to get it into their social media platform. It provides a real-time feed of who subscribed to what, which means the live editors can actually watch through the Stream Manager and some of the CMS API in terms of how many of our customers, like for example, if the BBC or the Washington Post is taking a live feed, then probably we need to expect a fairly large load in terms of how many viewers are coming in as well. So I guess depending on the customers, which stream is getting or taken, we can actually see a lot more. And I guess it's also important from the sales perspective as well, like which breaking news is being watched by who, really. So, and it also takes care of the addition of a slate video in front of a live stream, for example, because before a live stream, it's always like an empty podium, for example, and we don't necessarily know when an actual live event actually starts. Sometimes they also overrun, and I will explain why that's actually important from our perspective. So it provides, and this is also the interface by API gateway in between our, as I mentioned, the CMS, the actual streaming farm itself, and the Reuters Connect platform. But we love serverless, but there are certainly some complexities that just harder to overcome, I guess, once you move into that parallelized nature of Lambda, such as logging and monitoring, because it's quite difficult to, for example, trace down a Lambda function or a failed API call and actually match it up with an invocation ID that you maybe didn't put into your Lambda function. So a lot depends on your logging capabilities. And I guess with that, I do hand it over to Kirk, who is going to give a few information about how Datadog is trying to help with that and solve it.
Yeah, so as you've seen, Reuters heavily uses Lambdas to stay agile and build things that can scale to millions and billions of users, potentially, viewing their video streams. And so traditionally, Lambda functions have been difficult to monitor, especially when you're using step functions or doing any sort of concurrency, right? Something breaks in this unit of work, and then you have to find out all the downstream things that might have broken. And so that can mean bouncing back and forth between pages, trying to correlate and see what's going on. And so that's why Datadog has introduced a native place for all your cloud functions to live. And so this is going to incorporate logs, traces, and metrics all in one place. So we're working to make it easier to debug all of your cloud functions in one place. And so it works using CloudWatch logs, and X-rays to bring all your application performance in one place. So you'll be able to see a trace, and through that trace, see the entire request as it flows through your entire downstream process. And using traces, you can see bottlenecks in your code or where errors happen and arise. And so Datadog is very excited for you to try it out, and give us any of your feedback. We're going to continue working on this and continue improving it. So we really hope you get some enjoyment out of it. Thank you.
Thank you, Kirk. So let's look at an interesting challenge that we had to solve as part of this system. So the way we distribute our live streams to our customers is, as I mentioned, we use CloudFront pretty heavily. And basically how it works is, or what we do is, once a customer goes to the Reuters Connect platform, they subscribe to a live event, or based on the planning view, they can see that there is an upcoming live of maybe a Trump speech or something. They can subscribe to it. They get an eventized URL, and they can take that eventized URL and plug it into their website, because they just want to prepare for that particular speech happening. I guess it's different from a breaking news perspective, because then someone actually needs to quickly jump on it and take the stream itself somewhere, but you can subscribe to it in advance still. So we create an eventized URL that's based on CloudFront. And what really happens underneath is that once the consumer takes that really routes back to a load balancer to a particular region, depending on where the actual underlying stream originates from, right? Behind the load balancer, we have an Nginx layer just to offload some additional requests. I will explain that why. And then we have the stream engines with the GPUs and providing actual underlying transcoding capabilities. So because we sometimes change our mind in terms of which camera feed we want to use or which encoder we want to use. Potentially, we even want to change which region the actual stream is originated from, or there is a previous event that's overrunning on that particular encoder. We need to have the capability to replace whichever engine is providing the live stream for that particular live event without impacting the customer. Or maybe we want to ingest a particular video, for example, right? And that means is, without impacting the URL, without impacting the CloudFront distribution or whatever that's being given out, we need to have the capability to change the underlying EC2 instance that's providing live streams. Just keep in mind, we have done that before the Lambda Edge came out, because with Lambda Edge, you can now change origins as well. But interestingly, with this solution, what we did here, you could still do it quicker. Because what we're doing here, we're using the ALB functionality of path-based routing. So what we do is, via Lambda functions and via the stream manager, based on how we planned out a particular event, we can actually change which target group the application load balancer is targeting real time by just a couple of Lambda functions. And we can reroute where that actual live event is going to be originated from the encoder perspective. And as you can imagine, there are no additional requests or there is no additional time to figure that out because the logic is going to be pushed by the stream manager onto the configuration set of ALBs. So we can actually do an origin swap out quicker than you would do it with, for example, a Lambda Edge functionality, which is interesting, or potentially quicker. But I guess we're keeping close eyes on how you could do it with Lambda Edge too, because that could maybe make it easier. We have 2 layers of routing here, I guess, because we route in between which regions we're going to originate it from, but also we need to have routing capability in terms of how you route from ALB to the EC2 instance as well. So it's multiple ways of doing it. And what's interesting, this is really basically an SDI matrix, if someone is familiar with some of the broadcasting terms. It's really just a SDI matrix, or like how you would swap like a TV channel, for example. And I guess the takeaway from this is that I do recommend to everyone is certainly to utilize the ALB paths-based routing functionality to potentially change what's behind CloudFront or what's behind your particular URL as well, because it's really easy to configure, and you can just do it with the Lambda function. So what are the challenges that we dealt with and solved? So as you can imagine, CloudFront scales pretty well. ALB scales pretty well. But then the underlying encoder itself, can easily run into bottlenecks, such as its own network stack, for example. So what we did there, we created an additional layer of Nginx cache in between the load balancers and the EC2 instances. Because if you think about it as well, it's so much easier to just scale a T3 micro or a T3 small instance compared to scaling like a GPU instance up. It's so much cheaper, right? I mean, why would you not just have an additional layer that could help offloading your request counts? And because we're dealing with breaking news, like take the Thailand cave rescue story, like we had no idea, for example, when the first person would be rescued, right? So we need to be always ready for a massive scale, because once the first person was rescued, everyone was watching it. So we had to make sure that we have some additional capabilities and additional protection against any kind of request numbers that CloudFront and ALBs would be sending to us after they have scaled up, because they saw that it's a massive event. And that goes back to the ALBs again, because today you still need to do the pre-warming with by actually requesting a support ticket. And one thing we actually did there is, and it's also really critical, so when you know that you have a planned live event that's actually going to be massive and you use application load balancer, make sure that you actually raise a support ticket to pre-warm them, because AWS can actually go in and scale up your load balancers accordingly before the actual event happens, and it's really critical to do. One thing that you need to keep in mind that you need to have, depending on how you configure your load balancer, so if it's multi-AZ, for example, then you need to make sure that you have an underlying resource in all the AZs. What we actually did there, because we not always have an actual resource in all in AZs, because you potentially scale down sometimes, you can create some dummy rules and have like some rules to an empty target group, for example, and you can still request the pre-warming capability from AWS to do it, and they actually do complete that. The other thing that's probably worth mentioning here is the limits. So on CloudFront, there is a 100,000 requests per second limit and 40 gigabits per second limit. And as you can imagine, if you talk about live events like what we sometimes have, then those should be really considered. And it can potentially put you off if you don't pay attention to that. So as I mentioned, we do need to provide content anywhere. And sometimes it's really difficult. And I can easily say that internet delivery is still inconsistent, right? There are locations where you can have stable broadband connectivity and connection up to like 20 megabits, 100 megabits, 200 megabits per second. But there are regions where getting even 8 megabits per second or an HD stream is pretty difficult. And that's one of the reasons why satellite is still a player in this game in terms of live streaming. But we did solve the ingestion part in terms of the bonded cellular networks. So yeah, I mentioned frame rate conversion. That's a quite interesting challenge. And today we do that still with on-premise infrastructure. I guess at some point, real time, we can easily do that maybe in the cloud as well. But as of today, that's not something we can do. And what's critical here is the motion compensated frame rate conversion. So yeah, it's not just a normal, just adding another frame into the actual video itself. So one other challenge we had to deal with is that the streaming engines, or where we use hardware acceleration, we couldn't use containers because the third-party tool that we use on those engines didn't support NVIDIA or GPU accelerated containers. But then we used AWS SSM, which actually turned out to be perfect for us, not just because the parameter store capability of storing your licenses, for example, for your underlying streaming engines, but also from the perspective of managing your underlying streaming engines or your system without containers, for example, or that being completely serverless. SSM did give us that capability to remotely reconfigure instances, push out changes, change a license key, or whatever you name on a particular AMI or EC2 instance. So, as you can imagine, there's a lot we could change here. Like, you could, and even after all these announcements, like, you already probably thinking, like, how could you change your current infrastructure and what else could you do? But, we don't have enough time to always do that. But we did look at those in terms of what other capabilities we could use. And you probably asked the question, why don't we use some of the AWS media services? Well, I guess the few reason behind that is because we have some skill set already in media processing just because of our past. And we have some quite specific need because of the frame rate conversion we need to do. But we do keep a really close eye on the media services because it does turn out to be fairly useful for the format conversion piece and some of the video processing we could do. And also with some of the new capabilities in terms of low latency ingestion is definitely something that we should have a stab at and just to check whether we could potentially use it. Spot instances. I mean, it is something that we do utilize to test massive load and just our scale. But it's also something we did use for our archiving capabilities. So when we were actually crunching through all the video archive system, which has, as I mentioned, a couple of million clips, we did use spot instances to do those ad hoc processing capabilities. And, for probably third, fourth of the cost. So it's definitely something that I do recommend to everyone to look at spot instances because it's just, going to decrease your cost significantly. And there is all the new shiny and fancy stuff in terms of how you could use machine learning and deep learning and AI and cognitive computing in the media domain. And this is something that's pretty close to me because I have a personal interest in some of these as well. But even if you just think about the fact that there are certain requirements in certain countries, such as providing closed captioning, for example, machine learning, deep learning, perfect for that. You could create automated transcription real time for some of your live streams potentially, have it even potentially translated into multiple languages right after it actually comes into the AWS space, and there are already existing services you could utilize there. Then there are all the other concepts such as automatic story localization, for example, or story summarization, or potentially entity extraction, right? I mean, if you have a live stream about an actual particular speech or Brexit or some of those important topics nowadays, maybe you could potentially extract some of the valuable information real time from those live streams, create some additional metadata out of that and publish it and have the breaking news right away with all the necessary information that your consumers are interested in. And there is all the important piece from fake news detection, right? I mean, I'm sure we get to the point where we have the capabilities with generative networks to potentially even create videos of fake news. I mean, today it's mostly pictures and news metadata, but I'm sure we get to the point where someone would be capable of creating some videos that you couldn't even tell the difference in between whether that's real or not, or whether that actually happened or not. And I'm sure fake news detection is actually going to be even more and more important. Like even today, it's fairly easy to trick someone into reading a particular news on Facebook and then thinking that actually happened, right? And that is something that we need to keep paying attention to. And there is all the other aspects of voice-activated news, for example, like using Alexa, right? You could just call out and give me Reuters news or something, right? There are so many different applications of these technologies, and it's all something that we're playing with and experimenting and how we can actually bring it into production. But also, we need to make sure that we focus on the product deliverables. So the other one that's interesting, so I created these slides a couple of months ago, which was quite funny. And I did actually put down the idea of like I'm sure we get to the stage where, we want to get a live stream from the moon or the Mars or the ISS and, like just to make it so much easier. Like creating a satellite distribution today is really, well, I guess it's getting easier nowadays, but it was really expensive for us when we did it for the first time. And it's still not cheap, right? I guess what's good about it that recently we did start to see like Rocket Labs and SpaceX like shooting up stuff and coming back for a couple of millions compared to hundreds of millions. And I'm sure at some point we get to the stage where AWS is going to shoot up a few for us depending on demand. And this was the point where I actually wanted to put in a feature request for satellite ingestion. But interestingly, that was a service that just got announced a couple of days ago. So that was quite funny. But this is something that we need to keep on paying attention to, because I do believe that the satellite will have a massive play, not just in revolutionizing on how internet delivery works, but just also in data transmission in general. Again, it also still provides fairly low latency feeds as well. So, Reuters loves to innovate, and we also like to go back to our, historical roots as well. And what I did here is just some theoretical calculation of how much content, or how much time it would take to actually get the reInvent sessions from, Las Vegas to New York by using a pigeon. And I don't know whether you heard of it, but a pigeon actually can deliver or carry more than 75 grams. And if you do look at, for example, an SD card, for example, which is around 5 grams, a pigeon could actually carry potentially 70 or 80 terabytes of content if an SD card is around half a terabyte. And what's interesting about the pigeon is that it actually goes with more than 77 miles per hour. So you could actually get to New York within 32 hours, I guess ignoring the fact that you need to train it and practice and all that stuff. And if you look at the calculation of how much or how big is the actual, well, I guess I did the calculation when the session catalog was open, so I'm sure that there are much more sessions today, so it's not just 2,204 sessions. But if I turn it into multiple frame rates and into the actual bitrate calculation I'm doing, then it ends up around 60, 70 terabytes. So in theory, a pigeon could actually carry all the reInvent sessions or the videos to New York within 32 hours. Now, what's interesting about this is that if you compare that to the average US mobile network speed or the broadband connectivity within the US, it's actually much faster. I mean, this is not, so, this is actually not an original idea. So what you see on the top is so IP over AC is actually IP over avian carriers. And if you do put it into Wikipedia, you do find it. And there is actual RFC for it as well. So RFC 1149 is an actual RFC of someone creating a protocol around avian carriers and pigeons. And someone actually spent hours and hours in blog posts of proving how you could do it and just comparing the intent delivery versus pigeons. And I guess the reason why it's becoming, or the reason why it actually looks to be better, because the storage size is just expansion, just increasing exponentially. So it's increasing 3 times faster than the bandwidth connectivity that you get nowadays. So if you look at potentially using, 16 pigeons, let's say, with half a terabyte SD cards, and imagine it would take 1 hour to get to a destination, the actual throughput would be around 145 gigabits per second, which is quite funny. So it's poor latency, but fairly high throughput. I guess we need, if there are some packet loss, if there are some egos around, but in general, it could actually provide a fairly good speed. Maybe even could beat the snowball, who knows? And with that, I would announce Reuters Pigeon Express. If this wouldn't actually appear on YouTube, because I probably would get shot for this, but yeah. So that was certainly a joke. But if you want to look it up, you can find some more information about this. It's fairly amusing when actually someone digs into the calculations of how you could use pigeons to get from A to B and actually carry content for you without the training itself. And with that, that concludes my session. And thanks for listening. And please fill out the survey and give us feedback. It was my first time in reInvent, so I would love to hear your feedback. Thank you. I guess because we have enough time, I can open it up for questions if anyone is interested. Or
yeah, just a couple of things. I noticed on your architecture slide, you had pretty heavy use of Amazon S3.
Yeah.
And I was just wondering if managing the outbound bandwidth charges was a big challenge for you, and so if you have tricks as to how you could mitigate that.
So from X3 specifically, or from CloudFront, or?
Just the S3 charges. Is there a lot of outbound traffic?
We're not trying to put anything, so we're not trying to give direct, we always try to shield S3 with CloudFront. So whenever someone takes some content from our, even just video on demand, we have CloudFront in front of S3 by just default. So we don't serve content directly from S3 in most cases. We do ingest directly into S3 potentially, but we don't serve content directly. That's mainly because of the potential cost differences as well. If you reserve some capacity with CloudFront, you could actually get some cheaper deals anyway. But also because of the fact of acceleration. So with CloudFront, obviously, it could make it faster, and caching would also help you. But I guess the other segment as well, that we need to make sure that we serve our content out privately, and CloudFront gives the capability to sign your URLs, for example, and have some expiration days. So in general, what I do recommend is if you want to serve out content, just stick CloudFront in front of S3 and just do that. It's so much easier.
Okay.
Yeah.
And yeah, just to clarify, the question was about costs and outbound traffic for anybody following along. Yeah. On S3 specifically.
On the encoding front, how many file types do you guys encode your streams to, or do you not do the encoding? You offload that to the third parties?
So what's that there?
Just encoding the video file format. So I was wondering.
Video-wise, we do around 300, 400 files per day in terms of like actual news stories itself. In terms of lives, I don't actually know the number itself, how many breaking news events we get in as a live stream, but that depends on a daily basis anyway.
Okay, yeah. But the actual file format, how many different encodes do you do per stream?
That's a lot of different file formats, because like you can imagine from ingestion perspective, we get content in various formats. It might be just a simple MP3 or MP4 even, but all sorts of, and we need to deal with all sorts of compression techniques and formats as well. So probably around 20, 40 or something, I think in between, depending on whether we talk about the archive system or whether the normal just video feed. Because for the archive system, we do need to provide like ABCIs in ABCI 50, ABCI, all the other options of other compression techniques as well for higher quality. Because we need to, we give source content to our customers, which they then sell to our own customers as well. So.
You use Elemental at all? Do you guys work with Elemental in this?
We did play with it, but it's not like, because as I mentioned, we have some quite specific frame rate conversion requirements with motion compensation. It didn't. It's not something we should use, I guess, for that. Because underneath it's really just FFmpeg, right? So if you want, you can do it yourself.
Okay.
I guess we haven't looked at the latest one, the ingestion piece, the Media Connect, I guess, that just got announced. That's definitely something I want to look at. From the format conversion perspective, we did play with Elastic Transcode and then with the media or the Elemental option as well. But and from format conversion, it might turn out to be more cost efficient if you, I guess, remove the time and money you would need to spend to write it your own. So if you don't have anything to do it today, I do recommend it. But in our case, because we have built systems around video processing before those services even came out, obviously don't want to necessarily spend time to rewrite all of that into.
Sure.
Yeah, but at some point maybe we will. So yeah.
Thanks.
Thank you.
One more over there.
Hi, thank you. Thank you for the presentation. I have one question for Kik and one question for you, Romeo. How do you deal with, at your contribution signals are RTMP, how do you deal with the RTMP error, packet lost, packet errors? Because
you mean from the camera crew back to the headquarters itself?
How do you deal with the errors in the contribution network?
So some of that is also done. So as I mentioned, we use those bonded cellular connections, and in those cases, the protocol itself, that I don't actually know exactly what protocol is being utilized by it underneath, but that itself deals with that. So we don't have packet loss on that. Well, if you have packet loss, then because of this bonded capability, it will just retransmit it from another one. So it's pretty similar to how we would be doing it with TCP. On the satellite-based solution, the way we deal with it is we have forward error correction, which means we have like an additional 20–15% of extra packet we send with the satellite stream, which can then be which can be used to reconstruct the underlying video or the live stream potentially to avoid any kind of jitter or artifact issue, right? So yeah. We use quite heavy forward error connection, and depending on an additional backchannel layer via the internet if it's available, then that can actually tell that could you please retransmit this particular packet? And if we have many of our customers losing a particular packet because maybe in US there is a massive cloud or some, some really bad weather conditions, then we just retransmit those packets automatically if those has been lost, depending on what information we get back to the backchannel. So we use internet as a backup for the satellite, and we use the satellite as a backup for the internet. So it's like both ways, really. But we also apply all the techniques you can do with satellite and with internet as well.
Okay, thank you. And regarding Kik, as AWS have announced a lot of AWS media services, is there any plan is there any roadmap in the Datadog to support AWS media services apart from CloudWatch logs?
So just to repeat your question, you're specifically asking about CloudWatch and Lambda?
Yeah, specifically if you are in your roadmap to support AWS media services, Media Live, Media Service,
okay.
Media Package.
So if we're supporting media services?
Apart from the Cloud Logs
yeah,
events.
so we're always building new integrations. I know that one of the new service meshes that was just announced, we had it in the day of launch. So regardless of what the service is, we're usually working on it. So yeah.
I'd say because we use...
I can't share any internal timelines, but I can say that we work very hard to support as much Amazon
we
services.
use Datadog as a monitoring platform, AWS Media Services for transcoding services, so just to know. Thank you.
Gotcha. Yep, thank you.
Thank you.